In this video, we are going to evaluate expressions that contain a variable value in them. So before we talk about expressions that contain variables, we need to talk about what those two words actually mean. So first we see that we have the word variable, and a variable is a letter. So this is where we end up having letters in mathematics, things beyond numbers, and a variable is a letter that represents an unknown value. So it's something that we don't currently know the value of, but hope to know the value of in the future. Essentially what this letter does is it acts as a place holder. So it holds the place for the value of that letter until that value is known. The last key piece here that we'll see as we work with more complicated equations in the future, or when we solve equations that contain two variables, are that the values of a variable may vary or change. Hence the name variable. And an example of a variable, it can be literally any letter. So X, Y, Z, K, M, N, P, you name it. I probably suggest avoiding T and O because they look like 0 and a plus sign, but you can use those as variables as well as long as you're careful with how you denote them. Now, the second word we need to be familiar with before we move forward with this lesson is the word expression. And an expression is anything that contains a combination of letters, numbers, and or operations. And I want to talk through a couple of examples and non-examples of an expression. So an expression could be a letter, such as X. An expression could be a number, such as 10. An expression could be something that has letters, numbers, and operations, so like X plus 10. We could also have more operations, so say we had 2 times X plus 7 times Y plus Z. Again, that contains letters, numbers, and operations, so it fits the definition of an expression. Now, a non-example would be something that maybe contains more than letters, numbers, and operations. So something like 5x plus 3, that's an expression, but say it was set equal to 4. That equal sign results in this not being an expression, but being an equation instead. We could also have something like 5y minus 7 is less than 10. And again, this extra symbol in here that's not an operation, a letter, or a number, this inequality makes this not an expression, but an inequality instead. So what we're going to focus on in this lesson are expressions, things that contain letters, numbers, and or operations. Now that we have an understanding of what an expression and a variable is, we're now going to evaluate the expressions on this page. And when I say evaluate, what I'd like you to do is I'd like you to substitute, if you're given, a number for each variable. So we're given those values you can see right here. And then we're going to simplify that expression and we're going to use the order of operations to do so. So down below you see two expressions. The first one says 2x plus 3y. And you can see that up here in the instructions we're given the values of both x and y. So when we're asked to evaluate, we're going to substitute in values for x and y as we rewrite this expression. So here we have 2 times the x value right here is 2. Plus 3 times the y value is 3. And now that we've substituted in those variables, we're going to simplify. And we're going to use the order of operations to do so. So I know the order of operations goes parentheses, but I don't see any. Exponents, but I don't see any. And then I do multiplication and division from left to right. So here I see a multiplication, so that becomes 4 plus 3 times 3. I see a second multiplication, so that becomes 4 plus 9. And then my last operation is just to add, and I end up with 13. Now if I look at the next example, I see 4xy, and when things are smushed together, remember that's multiplication. So we're going to start this problem by substituting in a number for each variable. So I see x is 2 and y is 3. So I have 4 times 2 times 3 because I'm substituting in the values for x and y. I then am going to apply the order of operations. So I don't see any parentheses, don't see any exponents, but I do see multiplication, which I'm going to apply from left to right. So 4 times 2 is 8. 8 times 3 is then 24. So now we're going to up the ante a little bit, and we're going to solve some more complicated expressions that contain variables. So you can see here that these are much more complicated looking than the previous page, but we're going to apply the same idea. So we're going to start with example 3, and we're going to substitute in values for all of the variables. So I can see x is 4, y is negative 2, and z is negative 4. So here I start off, I have 4 times 5 minus 24 divided by x is 4, plus y is negative 2, plus x is 4 squared. And then from here, I'm going to apply the order of operations. So I start with my parentheses. So I rewrite the rest of the expression, but I solve my parentheses, which becomes 2. I then focus on the exponent, and 2 squared is 4. I then am going to apply multiplication and division from left to right. So here I have 20. And then I have a division. Now I'm going to rewrite this up here, so just for ease and space. Then from here, I'm going to rewrite all of my subtractions as keep, change, change. So this is really plus a negative 6. Then I'm going to do 20 plus negative 6, which is 14. And then add it with 4, which is 18. So if I substitute in my values and then evaluate the expression, I find that the expression is equal to 18. Now if I look down below at the next example, I have quite a few variables in that problem. So here I'm going to start the same way with substituting. So I have 6 times 4 divided by negative 4 times negative 2 minus 10 plus 2 times 4 plus negative 2 plus negative 4 squared. It's a pretty long problem. All right, I'm going to start with those parentheses and adding those values together. So I know that 4 plus the negative 2 is 2, plus the negative 4 is equal to negative 2. So when I evaluate inside the parentheses, what I find is that I have a negative 2 squared. Then from here, I do my exponents next. And negative 2 squared is 4. Now when these parentheses are smushed up to a number, that's implied multiplication. So I can add that now in there. Now I'm going to do multiplication and division from left to right. So this first one becomes 24. This second one, 24 divided by negative 4, is negative 6, and I'm going to rewrite that line here. So I have negative 6 times negative 2 minus 10 plus 2 times 4. Then have another multiplication, so that's negative 6 plus, times negative 2. And a negative times a negative is a positive, so we have 12, then minus 10 plus 2 times 4. Another multiplication, which gives me 8. I can then use keep, change, change here. Do my addition and subtraction from left to right. And I find that if I use my order of operations, I end up with a value of 10.